All right, for the last group of questions, I need to apologize big time because this is a major typo. It says consider the sequence shown, and it says describe the pattern. Well, as I'm looking at this, first of all, I've got polygons. The first polygon has 4 sides. The next one has 6 sides, and then the next one has 5 sides. Now, as interesting that is, I don't know where I would go from there. That's a very interesting sequence. I increased by 2 and then went down by 1. Maybe I could keep doing that. I could take 7 and I could increase by 2 sides, so it would be it increased by 2, and then which would be 7 sides, and then decrease by 1, which would be 6 again. This is not at all a sequence that we've looked in class, although I think this could be interesting to investigate. I intend something much more simplistic than this. So for this example, if you just think about switching the order of these two, all right. So here I've got polygons, and Mr. Roberts, we can't read your mind, but obviously I'm getting to talk to you about this, and we'll discuss it before we pass out our little tiny test tomorrow. But I am going from 4 sides to 5 sides to 6 sides. So polygons that are increasing by 1 side each step. I don't know, I'm just writing. Draw the next 2 figures in the pattern. Interesting. I've got a hexagon, right, with 6 sides. I don't know that I've ever drawn a 7-sided polygon. That could be interesting to try and sketch. 1, 2, 3, 4, 5, 6. Well, that's only 6 sides. Let's see. How would one sketch a 7-sided polygon? 1, 2, 3, 4, 5, 6, 7. Wow, I need to give you like a dot pattern tomorrow because that looks really rough. Here's 7 sides, right? Now I got to get 8 sides. Now, for some reason, 8 sides seems easier to me. 1, 2, 3, 4, 5, 6, 7, and that's because that's a stop sign. I can deal with that. So that's 8 sides. So there's the next 2. I gotta give you a simpler pattern tomorrow. Write a numeric sequence to represent the first 5 figures. Okay, that's pretty easy. I'm going from 4 sides to 5 to 6 to 7 and then to 8. Write an explicit formula for this sequence. Well, this is clearly arithmetic, right? And I have a common difference d that is equal to 1, and I have a first term that's equal to 4 sides. So if I was going to write this out, right, a sub n is equal to 4 plus n minus 1 times my common difference of 1. Fascinating. Write a recursive formula for this sequence. So that's pretty straightforward, right? I'll say the next value of the term in this sequence, next number of sides, is equal to the current one plus 1 more, right? Just adding that common difference. Determine the number of sides of the 10th figure in the pattern. Well, for this one, I'm definitely going to want to use 16. I'm going to want to use my recursive rule. So I'm going to write this down here. The 10th one equals 4 plus 10 minus 1 times 1. Oh, so I'm looking at 4 plus 9, right? 4 plus 9, so there's 13 sides on the 10th one. Really? Okay, I'll take your word for it. But really, the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th. Oh, there you go. 13 sides on the 10th one. And then finally, determine the number of sides of the 100th figure in the pattern. Well, you know what? I'm glad I checked this out, and I'm pretty convinced this is working because I'm not going to be able to count this one as well. So let's go ahead and use, you know what? It's pretty straightforward, right? It's the a sub 100, and that's going to equal 4 plus, parentheses, 100 minus 1 times 1. So here this is just 4 plus the number 99. So that looks like 103. Fascinating. Anyways, you guys have a good evening. Rest up. I'll see you tomorrow with a small test on Chapter 4.